Alright, so we are going to go ahead and work on finding the second derivative of an implicitly defined function. So notice the notation right here, okay? When you're working with an implicitly defined function, the first derivative, they usually say find dy over dx. This is what the second derivative looks like, d squared y over dx squared. So, you know, it looks a little bit funky, looks a little bit different, but all that means is the second derivative. That's it. Just means find the second derivative. So, working with this function, first thing we need to do, we need to find the first derivative. Okay? So, first derivative is going to be 2x plus 2y times dy over dx equals 0. Okay? And then to find this first derivative, I need to get dy over dx by itself. So subtract the 2x over here. So I get 2y dy over dx is equal to negative 2x. And then I'll divide to get dy over dx is equal to negative 2x over 2y, which I can just simplify to negative x over y. Okay? So that's my first derivative. That's stuff we've already learned in the previous lesson. Now, to find the second derivative of this, I need to just take the derivative of the first derivative, just like, you know, previous stuff. To get the second derivative, you have to find the first derivative, then you take the derivative again. Okay? So here, I'm going to use the quotient rule for this. Okay? And I'm going to just go ahead and make sure it's clear. I'm going to put that negative with the x, just to know which one it's with so I don't get confused. Okay? So what I'm going to do here for my second derivative, d squared y over dx squared, do my quotient rule. Bottom times the derivative of the top, so it's y times negative 1, derivative negative x is just negative 1, minus the top, negative x, times the derivative of the bottom. The derivative of y is 1 times dy over dx. So we have dy over dx here. All over the bottom squared, so all over y squared. Okay? So let me just go ahead and simplify this a little bit because I got these negatives in here. So this would be negative y, and this would be plus x times dy over dx all over y squared. That looks a little bit nicer. Now, at this point, I don't want to leave a dy over dx in my second derivative. I want to just have x's and y's left in there. So, what I do is I notice that just a second ago we found what dy over dx equals for this problem. It equals negative x over y. So I'm going to take negative x over y and I'm going to substitute it in where I see dy over dx. So it'll be negative y plus x times negative x over y all over y squared. Okay? And again, all I did here was, instead of writing dy over dx, I just replaced it with negative x over y. Now, you know, if I want to, I could simplify this, and I know I'm running out of room here, hopefully you can see this okay, to negative y, x times negative x is going to be negative x squared over y, and then all over y squared. So it's kind of an ugly complex fraction right there, but, you know, it still gives us what we want. That's the second derivative right here. I mean, actually right here we had the second derivative, and then I just simplified it a little bit. And you could actually simplify this one and, you know, make it so it's not a complex fraction, and actually with simplify I think you could, you know, end up plugging that in for something, but we're not going to worry about that. I wouldn't process the second derivative is more important.